Hello guys, welcome back to my channel. Let's solve today's POTD. So today's POTD is very simple. If we are given an array that contains length of different ropes, okay, and we need to connect these ropes from one to form one rope. The cost of connecting two ropes is equal to sum of their lengths. Your task is to connect the rope with minimum cost. So what is question saying is, suppose you have this array. So these are the lengths of. They we have four ropes of length, 4, 3, 2 and 6. So and okay, okay, 4, 3, 2 and 6, these are the length of. Okay, so what we can see, and what is the cost, like merging cost, you can say merge x and y. If there are two ropes x and y, and what will the cost, their length is x and y, so what will the length cost will nothing but length of x and length of y. Okay, okay, merging and merging cost to what are two ropes, so cost will be length of x plus length of y. And if you merge 4 and 3, so now there will be new row, there will the cost will be plus 7, like 4, length of this is 4, length of this is 3, so cost will be plus 7. But now what will the length of length of new rope will be 7, so it will become something like this. Okay, so what you can see, like if there are these rope, so what will give you the minimum costs? If you add minimum 2, this will give you minimum cost na. Okay, so what we will do, we will add these two, so what it will become here, right, cost. Okay, and so what it will become, it will, there will be cost of 5, and now it will become 4, 5 and 6. Why 5? 2 and 3. 2 plus 3 is 5. Okay, now this is our new array, you can say. Post is 5 now, and this is our new array. So in this new array, what we will do? We will do these two, because these two are minimum. So this will give minimum cost. What will be the cost of this? 4 plus 5, 9. So cost will be plus 9. And 4 plus 5, 9. So this will be the new array. Okay, we are merged 4 and 5 row. So now there are only two elements left. So what will the cost? Cost will nothing but the sum of these two. What will 9 plus 6? 15. So this is nothing but 29. So this is the simple case. So what we essentially needed? We essentially need, for a given array, for they will, let's suppose we have some numbers. We want two smallest numbers, right? For a given array or for a given set, you can say they are like bunch of numbers, and we want minimum two. Okay, so we have a STL thing, like we have priority queue. Okay, there's an inbuilt function of STL. What priority queue does? Priority queue keeps the maximum element on the top. Okay, if you insert in priority queue, if you insert 5, 3, 5, 8, 3, so it will become something like this. What is the maximum? 8, then 5, then 5, then 3, then 3. It will rearrange this, and if you remove this, then it will rearrange reptiles. If you add like you add 2, so it will find the location of 2. What will be here? If you add 6, 6 will be here. So if it will automatically rearrange, and will keep the elements in sorting order, like increasing order. Top highest element will be on top, and lowest element will be on lower side. Okay, and the other version of priority queue, if you use like in simple priority queue, we write this way: priority queue and data type. Let's say int. Okay, priority queue, let's suppose int pq. So in this, what will happen? highest on top. Okay, it will be sorted. Both will be sorted, but what will happen in this highest on priority queue heap? We say mean heap. We say priority queue int. This is just the way to write this mean heap. What will happen in mean heap? Mean heap. There will be order will be sorted, but GREAT greater int priority queue lowest on top. जैसे भाईचारा on top होता है वैसे lowest on top. Okay, sorted. Things will be sorted, but lowest will be on top. So you can, if you write this way, this priority queue will give you lowest element if you use pq dot top. Okay, so if you don't, you cannot remember this way, there is even simple trick. Like essentially what simple priority queue does, you will get here push negatives. Okay, like for simple priority queue, like if we are, okay, this is a simple trick that I use. Like let's suppose you have elements like 2, 3, 6 and 5. If you push in simple pq, let's say this is pq1 and this, let's say this is pq2. Okay, so if pq even you push everything, so what it will become, it will become 6, 5, 3, 2. But you suppose you are you don't remember what is that line, and it's not that was hard, but suppose still you don't remember, so what you can just do in pq1, push negatives. Okay, so push -2, so what it will become, if you push -2 will be here, -3 will be here, -5 will be here, and now take out the element, and x is minus of pq dot top. So what you have to do, essentially do, by the time, on the time of push, or adding to priority queue, you just add negative, and while you are taking out element, add the negative. This will give you the smallest element. Okay, so these are simple tricks, and what I have done, this is nothing but this is the cost we define priority queue. Here answer can be in long, so you also need to use long. If you don't want to use this way, okay, let me show that trick also there, so that things will be much more clear. Okay, here you can see I created, this is nothing but main heap. Okay, main heap, what main heap do, sorted and smallest on top. Okay, so this will give you smallest on top. So while there are more than one element in priority queue, we will take that first element and we will remove this element. We could not remove this element, we will take the now again first element, remove this. So this way we have taken two top element, that will be two smallest element. We have added them x plus y in the cost, because adding these will cost you x plus y, and we will again that this is, we again pushed x plus y, because why x plus y, because this is the length of new rope. Okay, so this way if there is only one loop left, we don't have to do anything, because now your motive was to convert it to a single rope. Okay, so this return cost one, or if you want to that, you don't want to write mean heap this way, so what you can do is this simple trick that can be useful for useful in many times. And suppose we are pushing pairs, so what for, so okay, let me understand that, I will explain that thing also, so that at least priority chapter will be clear for everyone who is watching this video. Okay, I am pushing negative, I will push the negative, and while I am taking out, I will also do the negative. So it means if x was there, we pushed minus x, and we took take out minus x, so again we will multiply it to minus cancel out, and it will become plus. So this is the, so this is the, let me run this. I know it will run. Okay, system got expired, whatever. I have to please refresh the page. Okay. Okay, this what is this? Refund solve problem. Okay, submit it. Or answer what? Why this? Okay, okay. What time opus? We didn't do the negative. Okay, that's why. Minus. Okay. We are generally pushing minus x, so it will become minus x. Minus if we multiply minus 1 with x plus y, so it will become minus x minus y. Okay, so keep as I mentioned, like it is necessary to, while we are push negative, while we are taking out push take negative, everything will remain same and it will work as min heap. So one thing I want to explain, one more thing that I want to explain is, suppose there are, okay, I'm explaining it for PQ. Simple PQ means max on top. Okay, maximum element of priority Q. Suppose we are pushing in pair. We are pushing two, three pairs. Okay, what is a pair? Two, three, five, six, and seven, one. Or let me take one another one. Like let's say five, three. So what will a sorted order? So in priority queue, what it does? First, it for like for it want like priority queue wants to compare which one to put on top. So it will compare any two, like these, the comparison between this and this. How comparison will happen? It will check the first element first. First element first. 2 and 3. Which one is bigger? 5 is bigger, na? So this will come on. This will come on top. For which element? These are four element for which first you can say first element is bigger. For this it is 2, it is 5, it is 7, and it is 5. For this one it is bigger, so 7 comma 1 will come on top. For now, how much are left? These three are left, but there is one issue, like for this and this, first element is same, so which one will on the top? So for this 5 and 6 is same, 5 and 5 is same, so then it will move to the second. If first same, then like compare x a and b. If a dot second, as I'm like it, if a dot second is greater than b dot second, top will be a. Or if they are equal, if now, okay, okay, a dot first, sorry, let me raise this. So question we have done, but I want to explain it so that if you in future you need this, to you can use. So we are comparing a and b. So if a dot first, f means first, is greater than b dot first, top will be a. Top a means a will be above the b. Okay. Else, okay, else if a dot first, there is total three condition, na? If a dot first is greater than b dot f, b dot first equal v dot first, and less than. So in this case, and this is the third case. In the third case, top will be big, because this is not the case, this is not the case, so definitely this means a dot f is less than b dot f. So in the case of equality, so if first element of both element is equal, then which one have higher second element? So if a dot second, the a dot second greater than a dot, sorry, b dot second, top will be a. or you can say equal also, because if something like this 3 and 5 and 3 and 5, 3 equal, then we are checking this, and suppose 5 and 5 are equal, so no matter which one is on top, because both elements are same. Else, if it is a dot, else what will the condition? Top will be b. This is like case 3.6 and 3.8. 3 is same, but second element of b is greater than a, so b will be on top. So what we do, we will first check the first element is higher for this 7 and now check, now again for this and this first element is same, so which one come above, which one will go on upper side? 5 6 will go on upper side because it has higher second element compared to this, because this has 3. Now 5 3 will come first, second, on fourth position. What will come? The rest element. So you can compare. 7 is bigger, 6 is bigger. For this highest, 7 is highest, then you can choose 5 is same, so 6 is above, and 3, and then 2. Okay, so this way sorting works in priority queue. So I hope you and learn a new topic and got clarity on priority queue. Please subscribe my channel if you like the, if you enjoy the video. Thank you.